So SnapEarth is the acronym of the project. Its full name, okay, now you can see it. Sorry for this. Its full name is Fostering Earth Observation Market Uptake thanks to natural and holistic access to added value data generated through cutting-edge artificial intelligence technologies. It is a project funded by the European Commission and belongs to the College 2020 Space 2019. It has started in 2019, and now November is, as Rati mentioned before, our last month of the project. The project is comprised of 7 participants from 6 EU countries. As you can see, our consortium includes not only universities and like the Middle East Technical University, but also research centers, SMEs, and other companies like Aptiski Polska, CS Romania, ISARTSAT, CS Group, and Quant. The scope of the project is to facilitate access to Earth observation data for the general public and introduce novel and innovative services in order to enable the automatic extraction of semantic information from satellite images. The obstacles that many people that would like to use EO data nowadays face are that these data are not included in the search engine that we use most of the day. They cannot be easily accessed by the general public. Search on the precise image is difficult due to the large amount of data available, and they cannot always be exploited due to weather conditions such as clouds, for example. Also, multiple resources are required for the processing of such data images. So, right now, through the SnapEarth project, what we're trying to do is to introduce innovative approaches to facilitate the access to EO data, enable automatic extraction of semantic information from satellite imagery, build a big data computing platform in order to allow all users who would like to use such information and in order to process them, to use this platform and create on-demand AI-ready high-performance and big data platforms. We develop general public awareness to EO data and aim to increase it in order to engage more users to use this information. We initiate the creation of a virtuous cycle of innovation by providing to EO data users an innovative platform with leading edge EO datasets and technologies, and aim to foster the market growth of Copernicus in order to develop new Earth observation services and applications and increase job positions on this field. The impact that we aim to have from the project is to establish sustainable supply chains for innovative EO value-added products, demonstrate complete integration into the customer's existing or new business processes, enhance European industry's potential to take advantage of the market opportunities and establish leadership in the field, and also lead to new or improved products in order to give these services to the market. Right now, this is the architecture of the SnapEarth project as we have defined it through its beginning. SnapEarth components are 8, and they are comprised of both services and the main platforms such as SafeScale, EarthSignature, and EarthSearch and EarthSelf. So I will go through this to give you just a glimpse of what each of these components includes. However, we will see a more detailed presentation of each one of them through the rest of the workshop. At first, we have SafeScale, which offers an API and a CLI tool to deploy versatile computing clusters that span multiple clouds. It is compatible with several cloud and IaaS providers. The next is EarthSelf. EarthSelf allows on-demand provisioning of EO data exploitation environments without having to manage the allocation of the necessary IT resources. The third component is EarthSignature. EarthSignature aims to extract the physical land cover semantic information from satellite imagery. It indexes the extracted information and links them through EarthSearch to the Quant's web search engine. Through EarthSearch, as we mentioned before, a user can post a natural language query on satellite image and receive all the multimedia. Yeah, please, go ahead. Someone would like to ask something? Okay. Continue. Okay. And receive all the information that would like on the satellite image that the user searches. For example, the user would like to search for satellite images. He uses Quant's search engine, and by posting anything that the user thinks that a proper query in order to search for the satellite images, the Quant's web search engine gives him all the results about these images that they have collected. Our fifth component and first service is Earth Climate. Earth Climate offers stakeholders a tool to monitor air quality thanks to the information obtained from satellite images without the need for own analysis of satellite images. It enables the monitoring of urban heat islands and supports the process of data analysis of areas of the user's interest. As you can see here, these are some of the user interfaces, some images from the Earth Climate user interface, for which we will discuss later in the workshop. The sixth component is Earth Food Security. Earth Food Security is a new innovative service based on further exploitation of soil moisture data and the related water availability for food security semantics. It's a new innovative service that facilitates the request and exploration of EO-based high-resolution soil moisture data and drought indices for large-scale applications. The seventh component is Earth Agriculture. Its aim is to propose to agriculture users a set of added value services to support agriculture monitoring activities, for example, crop type monitoring, grassland monitoring, ecological focused area practices monitoring, etc. And our last service and component is EarthPress. EarthPress is a web-based platform that facilitates journalists the procedure of news article synthesis. It is a platform that provides ready-to-print multimedia content to the journalist, including information from satellite images. Here are some of the contact details that we make available for you in order to receive more information about us and about the project.